Now let's see the third case of integration by parts. Here also only one function is present, but instead of taking the second function as 1 as we did in second case, here what we have to do is the given function itself can be written as a product of two functions, and then we integrate that using parts. Now that is because once we factorize or write the given function as product of two functions, out of those two functions one might be easier to integrate as with respect to the other one. So therefore we can use the integration by parts. Right. Now let's see one example. Here suppose we want to integrate sec cube x. Right. Now here we see that if we break it as sec x into sec square x, now you see that sec square x is easy to integrate because its integral is nothing but tan x, isn't it? So that is what we consider here, and now we use the integration by parts. So that is first function into integral of second minus derivative of first function, that is derivative of sec x into integral of sec square x dx, and everything integrated with respect to x. So that further gives us sec x into integral of sec square x is tan x, so that is tan x minus integral of, now derivative of sec x is sec x tan x, isn't it? So we write sec x tan x, but we observe that the integral of sec square x is nothing but tan x as we have done in the previous term. So that tan x we can merge with the previous tan x and write it as tan square x, right? Now moving ahead, we have first term as it is, that is sec x tan x minus, now see, to integrate sec x into tan square x, what do we do is we can write tan square x as nothing but sec square x minus 1, isn't it, dx. So that gives us further sec x tan x minus integral of, now sec x into sec square x is sec cube x, isn't it, and the second term will become plus because there are two minus signs, and then integral of sec x dx. Now if you observe, this term is precisely the integral that we started with finding out. So if we call this particular integral as I, so the left hand side is I, so this term which we got on the right hand side, that is also nothing but I, and we can bring that term on the left hand side to make it 2i as equal to sec x into tan x plus, and lastly the integral of sec x as we know is log of sec x plus tan x. Plus, if you want, we can write it as say c1, and finally let's divide both sides by 2, so we will get half into bracket sec x tan x, which is the first term unchanged, plus log of mod of sec x plus tan x, and the constant c1 by 2 we can term it as a new constant by c. So this is the final answer. That's how we have seen this special case where a single function is broken as a product of two functions.